Hi, my name is Kajal Galotra and in this video we will be talking about consistent hashing. We will start with the time where we used to have only one server for receiving all kind of requests. In this image I have shown you that all the requests are landing onto the same server. The traffic was all the requests could be served by one server. But then the problem started when one server was not able to serve all requests. So now let's talk about when we wanted multiple server to be in place in order to receive all the requests. I'm assuming that in order to serve all requests coming from the browser, we wanted multiple servers. So right now we have 4 server in place, server 0, 1, 2, 3. Now all the requests which are coming from browser, I'm assuming they have a unique identifier by the name called request ID. Okay, for simplicity I have taken request ID 56789. Now this is kind of a load balancer. We have Nginx here, but it can be any other load balancer as well. Now this load balancer work is to balance the load onto all the servers. Whenever a request will come, we will calculate the hash on a request, and according to the hashes we will redirect the request onto that server. In order to calculate the hash, we have this hash function where the hash function is request ID %n, where n stands for the number of servers. For request ID 5, as the hash came out to be 1, it will go to the server number 1, which is here. Then 6 %4, so it will go on to server number 2, which is in our case this server 2. Then hash of 7 will be 7 %4 equals to 3 here. Then 8 %4 0, so it will go back to the 0th server. Similarly for hash 9, 9 %4 equals to 1, then it will go to the server number 1. So on server number 1 we'll have a load of 2 requests. On server number 2 we'll have again load of 1 request, and on server number 3 we'll have a load of 1 request again. It was working fine, but now let's assume that we want to add one another server to this architecture. So in this picture you can see with server 0, 1, 2, 3 we have added one more server, which is server number 4. So now let's see with the same hash function what are the changes that will be happening. Okay, so the hash calculation, we have the same hash function, which is request ID %n, where n is the number of server. Earlier the number of server were 4, but right now the server number is 5. So we will calculate the hash for the same request IDs again. Now you can see hash for 5 is 0. So this 0 request with request ID 5 will be going to the server number 0. The hash of 6 which will be 6 %5 equals to 1, which will now go to server number 1, but earlier it was going on to server number 2. So that means the reshuffling of the data will be happening for all the servers. It's not like that only one server is impacted, but all the data is getting reshuffled because of adding one server or maybe with deletion. The point is, with this approach, addition or deletion is not an easy task because it will impact all the servers. So this was the major drawback of this. Then consistent hashing came into picture. Consistent hashing is an effective way to manage the load over the servers. So we consider instead of considering the servers in a linear form, we consider all the servers are present as a ring. So again the request will be coming from the browser, then it will land onto this load balancer, and now we are assuming the request IDs are bigger numbers. So we have taken request ID 300, 400, 600, 900 and 1200, and in this case instead of saying the server as 0, 1, 2, 3, we again have 4 servers, but the servers are, the server names are little bit different. So this is server 0, server 90, 180 and 270 for more clarity. Now we have another hash calculation mechanism where the hash function is request ID divides by 360 into 100. Okay. So now whenever a request is coming onto this Nginx server, then we are calculating the hashes. Okay. How consistent hashing will work? So consistent hashing will not go to the exact server like in the previous case, but instead it will go onto the next immediate server in the clockwise direction. For example, let's say if I'll calculate the hash of 300, which comes out to be 300 divided by 360 into 100, which is 83. Instead of going on to any server by the name called 83, it will number 83 is in between 0 and 90. It will be somewhere here. Instead of looking for the exact server number, it will just go on to the next immediate server in the clockwise direction, which in our case it is server number 90. Okay, so the server 90 will get the request of this request ID 300. Now in the next case, which is hash of 400, it is 111. In this case, the 111 will be lying somewhere here between 90 and 180. So then it will go onto the immediate next server in the clockwise direction, which is server 180. So the request with request ID 400 will be landing onto server 180. And similarly for 600 it is 166. So 166 will be again somewhere here. It will again land onto the server number 180. Then we have 900 request ID, which is 250. So 250 will be here. So that will be going into the server number 270. Similarly, hash of 1200 is 333. So this server 0 is equivalent to 360 because we have the angles from 0 to 360. That's why we have the naming convention like this. Now 333 will be in between 270 and 360, so it will be going on to server number 0. So after the distribution of all the requests, we'll have the request ID 1200 on server 0, request ID 300 on server 90, request ID 400 and 600 on server 180, and request ID 900 on server 120. So all these three servers will have only one load, but this server will have two requests load. Now let's try to see what will happen in case of addition of any server to this scenario. In this case, when we have added a server by the name called server 120, now we do not have any changes inside my hash function because 360 still remains the same. It does not even matter that how many servers we have, but hash will remain the same. So in both of the cases, hash of all request IDs are exactly same. Whenever a request ID will come onto this load balancer, the load balancer will be taking request onto all servers. All the requests will land onto the same server except for the request ID 400. For the request ID 400, we have a hash which is 111. For 111, the next server will be server 120 in the clockwise direction. So that request will be landing onto server 120, and all the data which is present on server number 180 for request ID 400, that will go from server 180 to server 120. That means only one server is impacted in this case. All the servers which were working earlier will work exactly similar like they were working earlier. Only the changes will be happening for the server number 180. So the point is, in the previous case, whenever we were adding any single server, the data was getting shuffled for all the servers available. But right now, whenever we have added any server, only some data has been reshuffling. So that's how addition to the server becomes easier. Now let's talk about whenever we will delete one server from the existing case. So I have gone back to the previous case where we had 4 servers, server 0, 90, 180 and 270, and hashes are exactly same. Now let's say we have removed this server. So in that case, what will happen? for request ID 300, the hash was 83 because 90 server is now not present. So the request ID 300 will be going on to the server number 180. Similarly for 400 and 600. So in that case, you can see that half load has come onto the server number 180. So the point is that whenever we are removing any server, the load onto that server can be increased. This can be one drawback whenever we are doing the consistent hashing. But this can also be removed by using some virtual server. But you got the basic idea that whenever one server has been removed, all the data will be going on to the next servers. We only have 3 servers, okay, which are represented by yellow, blue and red. Okay, so instead of keeping them only at one places, we have kept them at multiple places virtually. Server 1 will be taking some requests which will be in between the hashes between 40 and 80. Again the red server will be taking the request for which the hashes will be greater than 120 but less than 185, and similarly the red will be taking between 185 to 200. So the point is we have a hash function for the servers as well, and once we have hash, we'll be putting our servers at multiple places virtually, and in that case all the servers will be taking requests for different hashes. Now let's assume that the blue server gone. So this blue is gone, this blue is also gone, and this blue is also gone. So whatever requests that was handled by this server 40 will be going on to server number 80. So some load of this blue server will be going on to this red server. Similarly, some server from this blue servers will be going again back onto this red server. But here, whatever requests were handled by blue server will be going on to the yellow server. The load will be divided onto all the servers instead of putting it onto the same server. So that's how the virtual nodes are making differences, and this is better than the previous approach. Thank you so much for watching.